Good day everyone. Today we'll be discussing about sets. But first, let's define what is a set. A set is a collection of well-defined objects wherein these objects are called elements of a set. There are two ways of describing a set. The first one is the tabular form. The tabular form is a method of describing a set wherein the elements are separated by commas and enclosed by braces. Let's take set A. 2, 4, 6, 8. 1. The second way of describing a set is the rule form, wherein it makes use of the description X such that. X such that X is an even integer less than 12. There are kinds of sets. The first one is the equal set. Set A and set B are said to be equal if they have the same elements. Let's take the first example. 3, 2, 5. And set B, 5, 3, 2. Notice that they have the same elements. The second kind of set is the equivalent set, wherein set A and B are equivalent if they have the same number of elements. Let's take set A, B, C, and D. And set B, 1, 2, 3, 4. Notice that they have the same number of elements. The third kind of set is the finite set, wherein A is finite if it contains only a countable number of elements. Let's take set A, 3, 6, 9, wherein these numbers are countable. The next kind of set is the universal set. It is the totality of elements under consideration. Let's take, for example, 1, 2, 3, 4, A, B, C, and D. Our next kind of set is the disjoint set, wherein there is no common element. Let's take set A, L, V. It is said to be disjoint set because there is no common element in set A and set B. Now let's proceed on the operation on sets. The first operation is the union of sets, wherein A union B. Let's take, for example, set A, 2, 4, 6, and 8. For set B, we have 3, 2, 5, and 8. Wherein, as we can see, the common element is 8, 2, here. So we can write here now 4, 6. For the set B, 3 and 5. For the common element, 2 and 8. Our next operation is the intersection of sets. A intersects B. For example, let's take set A. 3, 2, 5, and 7. For set B, we have 2, 4, 6, and 8. For the set A, we have 3. For their common element is 2. We will write 2 at the center there. And for set A, 3, 5, and 7. For set B, 4, 6, and 8. Then we will shade the middle part, the intersection, because A intersects B. The next operation is the complement of A, wherein a set of all elements in the universal set but not found in A. We read this sign as A complement, and this represents our universal set. So when we say A complement, it is from this given, it is the 4, 6, and 8. So, as we draw along here, from the definition itself, a set of elements found universal but not found in A. So we will shade all the figures except the circle A. And for our last operation is the difference of sets, wherein set of all elements are found in A but not in B. Difference of set. So, from these given elements, the set of elements found in A but not in B. So, we have here the elements found in A, 3, 5, 7. And we did not include 2 because 2 is included also in set B. So we will shade only the set A, not including the 2. Thank you for spending some time with me. Hope you learned something from our lecture. This is Karen Lagi signing out.